Hello, so today we are going to do this problem called Flatten nested list iterator. So what we have with this problem is a nested list of integers, and each element is either an integer or a list. Okay, and these lists also can be nested, so you can have something like this, and then another list inside it, and maybe an element here, and then another list. And the goal is to implement a nested iterator that has next and has next function. This one returns the next integer in the iterator. So let's say we have maybe 1, 2 here. First we return 1, and then we return 2, and then we return whatever is next. Has next just returns if there is still elements left or not, if we are at the end of our list or not. And the code that will call our function is result here, and while there is a next, so we call has next, we get the next element and then we add it to the list. One thing to note here is that before every call to next, we do call has next. That is guaranteed by the problem. That will help us later in the implementation. So let's take a look at one of the examples they have here. So we have this list. For the first one, nested list is the first element of the nested list, so 1, and then after that this one, and then this one, and then this one. So you can see it respects nesting. This is also another interesting example. So first this element, and then the one in the nested list, and then one in the with depth 3 here, which is 6. So that's the problem. Now let's see how we can solve it. So the simplest solution is to just wrap the list, the nested list, flatten it in the constructor, and then have an index that marks the position where we are at for next, and each time just get that position and increment it. That's the simplest solution, although it's not ideal because then we are not implementing a real iterator. So definitely not the recommended one, but it's a good place to start. Okay, so let's just see that one and then go from there to a real iterator solution. So for that solution, we can have in our init function, okay, we are going to create an array that represents the list completely flattened. Okay, so to flatten the list, we'll go through the element of the list, and for each of them flatten it, and then just add the elements in values. Okay, so how do we flatten it? If the element is an integer, then we don't need to do anything, we just add it to the list. But if it's a list, then we get all the elements in it and recursively call helper, so that if it's an integer, we just return it. But if it's another list, then we iterate again. So very simple, and then we have the pointer that starts at 0. And for next, we get the element, increment the pointer, and return it. And for has next, we just check if we reach the end of the completely flattened list. So this one is very simple. However, it's not ideal because we already constructed the list. We want to implement a real iterator, so let's see how to do that next. One thing to note though is instead of an index here, you could use a stack of the elements and then reverse them, and then you can pop each time, or you could use a queue and then each time pop from the queue instead of maintaining an index. So that's also a possibility. Okay, so let's see the next solution. Okay, so let's see how we can do a solution with an iterator here. So the idea of this is, what we want basically from this solution is first return 1, then return 2, then return 3, then 4, then 5. So regardless of the nesting, we want to return the elements, the first element, right? So what we can do is just have a stack that contains the element. And each time what we want is, the invariant that we want is at the top of the stack. That's the elements we want. That's the next element. So this is the invariant we are looking for. So to do this, what we can do is basically add to a stack this list, reverse it, so that 1 is at the top, right? And so if we do that, what that will mean is this here is the first in the list, this list here, right? This is the first element. Then after that we'll have 4, then after that 2, 3, then 1. So what this allows us to do is in next, we can just, the next function call, we can just do, this is our stack, we can just do stack pop and return that. Okay, and just return this. Okay, but for our next function, so we would remove 1 and we'll return it, and that's what we expect. But for our has next function, remember in the problem statement it says before every next we call has next. So what this would mean is in has next we need to unwrap this, right? We need to transform this to be 2. What's the first element that we should have? To be 2, 3, 4, and then this will stay the same until we get to it. So we need to unwrap each nested list in has next so that it's in this order, right? The order where when we pop we get the first element. So that's what our has next function will need to do. So how can we do that basically? So we need to just pop. We need to just check the top of the stack, and if it's an integer we don't need to do anything, like here in the case of 4. But if it's a list, we need to do the same thing we did at the start, which is add to the stack, basically pop the list itself and add it to the stack in reverse order so that the first element is at the top. In Python we can do it like this. Okay, so what our has next function will do is just keeps iterating until it finds an integer, because what we want is top of the stack, next element, and an integer. This is what we want. And so has next will prepare for next to do that. And so what we will do here is, while we have a stack, what do we want to do? So we want to get the top element, right? And if the top is integer, then we can just return it. We can just return that we have an element, right? So we can return true. But if the top is not an integer, right, like in this case it's a list, what we want is to pop this and instead enter 2 and 3 in our stack, right? So we can just take the list, reverse it, and then add it to the stack. And so to do that, we have the top that we want to add, and so we can just take the stack, pop the elements out of it, and then add it again, but reverse it. Add the top, which is 2, 3, in a reversed order. So that would be just taking the top in reversed order, which is top minus 1. Okay. You get the idea, so minus 1 here. Okay. One thing here, we shouldn't do append, we should do extend, because we are adding a list in Python. Okay. So this is the idea. But if we end the stack and we didn't find any integer, although we kept popping, let's say for example in a case where we have a stack like this, where there is an empty list and an empty list, right? This can happen with something like this. Then we won't find an integer, and the stack would become empty after traversing these two, and so we need to return false at the end. Okay. So this is the simplest idea. Here at this top we'll need to call top get list to get the elements, right? Now you may ask, what about the case for 5 and 6 here, right? So what will happen is that what we'll add to the stack for this is 5 first, and then the list 6, and then the list 6. And so in the next iteration, we will get the elements of the list, and then we will add them as just 6. Okay, so this will work each time, right? Yeah, so that's the main idea, is to each time we unwrap the list that we are at, and we add it in reverse order to the stack, so that the first element is at the top, so that we can pop it in the next function. And the invariant we are expecting is that the top of the stack is always a single integer, and it's the next element. Okay, so let's code this up and make sure it passes test cases. Okay, so let's code this solution up. So the first thing we need to do is to have initialize our stack, and we need to initialize it, as we said, to the reverse of this nested list, so that the first element is at the top. The second thing we want to do is make our next function just return the top element, because we make sure that that top element is an integer. and it's the next integer. And this is possible because in the problem statement we are guaranteed that has next is called before next. And now in our function here, we want to iterate while there is a stack, right? While there is a stack, we want to okay, so while there is a stack, we want to get the top element, and then after that we want to check if it's an integer. So if it's an integer, we want to return true, of course, because then we found an element. Otherwise, the top is a list, so we want to pop it and then enter the element in a reverse order. And so to enter them, we extend the stack with the list in the top, right? So this will, instead of having 2, 3 in the top, we'll add 3 and then 2 after it in the top of the stack. And then if we weren't able to find any integer in the stack, then we return false. Okay, so let's run this. Okay, more examples. Okay, so it looks like there is something out of order. This is because we did not reverse here. We need to reverse so that 2, for example, for this list, we want 2 to be at the top. So if we just extend with 2, 3, then 3 will be at the top. We want to do the reverse to add 3 and then 2, so that 2 is at the top. So that's why we need to reverse the list. Okay, and this should pass, so let's submit. And this passes test cases. Now with this solution, next is O of 1 because we are only doing one pop. And has next is O of n because we do as many elements in the stack as there are. And so with the number of elements in the nested list. Okay, so this is one way to solve it. Another different way to solve it, but still in an iterator way, is to maintain track of the, not reverse, but just maintain where we are, the position where we are in the, while iterating in a stack. So let's see what that will look like. Okay, so in this solution, the idea is to maintain in the stack the position. So let's say our stack here. So what we want to do is maintain the list and the position. So let's say, let's actually make our stack bigger here to understand our solution. So in the stack, each element will have the nested list, and then the index that we are traversing. So what this would mean is first I would be here, and we will put the entire list in the value 0, right? Because I is 0 here. In the next iteration, I would be here, so this is what the list in the stack, right? So the current list we are looking at, that's what would be at the top of the stack. So what I mean by that is that, let's copy this here, because the first thing we will do is add the list in the stack, the entire list, right? With the position where we are at, which is 0. Okay, and so what happens? So that's what we start with from the initialization. Now, what do we do for next? What should we do in the next iteration? So what we need to do is get the top of the stack, right, so that we can get the position, and then return that element, right? If it's an integer, return that element. What we need to do is advance the index, right? We are here first at 0, we need to advance the index to 1, so that the next iteration we go to the next element. So to do this, what we need to do is get the top of the stack. So to do that, we just get our nested list and the position, and that would be the top of our stack, which is in Python just -1, which is the element at position n -1. And then we want to return, what's the value? The value is the nested list at position I, right? So first it will be position 0, we'll get 1, and then we need to get the integer, because next we'll need to always return an integer. So what this would mean is our hasNext need to maintain that at the top, the element is always an integer. And so here, once we return that element, so this is I actually, we need to increment this here. So what we do is we take the stack, the top of the stack, so we say stack at last position, that's the top. What we want is to modify this, which is at position 1. We want to increment it. Okay, so this is what next does. Now we need our hasNext to always maintain that the element at position I is an integer. So how can we implement our hasNext to do that? Okay, let's explore that. So hasNext. So what our hasNext function can do is check the top of the stack again. But since we may, for example, have something like this, to a nested list, we need to keep going until we find an integer, because we need hasNext to maintain that the top of the stack at position I is always an integer, right? So what we do here is we do while stack. We get the top of the stack, right? Position -1, that's the top of the stack. And so we will get an element. We don't know if that element is a list or an integer yet. But what we want is to check. So let's say we have 2, 3, right? And I is at, we incremented I in next, and it's equal to 2, right? That means this list is done, right? And we need to go to the next list. So let's say we have maybe 3, 4 here, 5. We need to go to this next list. So that's why here we check if I is equal to the length of the element. Then we want to go to the next list in what was previously in the stack, right? So what this would mean is basically we need to pop this out of the stack. So let's say we added 2, 3 to the stack, right? And then our I is now here. So it's bigger than the length of 2, 3. That means we need to pop this. We need to pop this to here. And of course add 4. Okay? Or add the entire list but have I at this position, right? And so what we need to do here is if this is equal to the length, we need to pop the top of the stack, because that means that that element is done. We finished traversing that element here. Okay? Now otherwise, what should we do? So otherwise, we have two cases. Either the top is just an integer, 4, for example, and we can just return it, or the top is a list, and then we need to expand that list, right? And so to do that here, so we check if the element at position I, right? Let's say I, for example, is here at position 2. We need to check if this is an integer. If it is, we know that we have a next element. We can just return true. And next, we'll just get that. We'll just get that element and return it, right? Otherwise, it's a list, right? So what we'll need to do is make the top of the stack be that list. So otherwise, it's a list. Let's say, for example, for this 5, 6. That means we need to append this list and put I at 5 so that next here returns it. And so what we need to do here is append to our stack the new list, right, which is element at position I. We get the list and start at position 0. But before doing that, right, because let's say here we are at this position I, and maybe there was an element here. Once we append this list, we need the I for the entire list to be incremented as well, right? And so what this would mean is here we need our stack before adding the element, we need the top of our stack to be incremented. For the next time when we pop this list, once it's done, we want to go to the next element in the rest of the list, if that makes sense. Okay. So this is the main idea. Maintain the list we are looking at in the index. And then for next, get that element at that index. And then for has next, each time we check if we are at the end of that sublist, go to the next list or the next element in the top level list, essentially. So yeah, this is pretty much it. Now let's code it up and make sure it passes our test cases. Okay, so let's write this solution here. So first we need to have our stack, right? So we need to define our stack here, which let's say it's equal, it starts out with, just as we said, the nested list at position 0. And for next, we need to just pop the list from the stack. So we need to get the top of the stack, increment it. So this would be self.stack. And what we need to return is the element, right, where we were pointing at the top, because the top is the element that we need to return next. And we need to get the integer. Okay. With has next, we guarantee that this will give us an integer, so we don't need to check. Now for has next, what we need to do is, while we have a stack, and if we exit and we didn't find an integer, then we can return false. Here we need to check the top of the stack, check what's there. Either the list we are looking at ended, and so that means it's equal to the length. Then we pop that list, and the next thing we traverse would be whatever is at the top of the stack after this, right? And then here, otherwise we will check. If the element we are looking at is an integer, then we are done. We know there is an element, so we return true. Otherwise, we know it's a list. And so what we need to do is definitely append that list, which is basically just element get list. But we need to specify what is the position, which is 0 here, the start position. But we shouldn't also forget to increment the previous step, right? Because once this one is done, we want to go to the next one. If we don't increment, we will get to the same list and traverse it again, right? And so that's pretty much it. So let's run this. Okay, it looks like there is a small issue here. So we check if it's an integer, which turns true. Yeah, this is element at position I. That's what we determined is a list, because that's not an integer, so it's a list. Okay, let's check if it passes test cases. And it does. In terms of time complexity, here we are only doing O of 1 operations, so this one is O of 1. Here we do at most the number of elements in the stack, so it's O of n. Yeah, so that's pretty much it for this problem. Thanks for watching. Please like and subscribe, and see you on the next one. Bye.